Hello, welcome back to another Jamovi tutorial. Today we're going to be covering something called a repeated measure. Sometimes this is shortened to RM ANOVA, or repeated measures analysis of variance. Today we're going to be working with the research question, looking at if an athletic intervention improves the bench press maximum weight of athletes over 3 different time points. And we're going to be making sure that we have met the assumptions of this analysis, that we know how to conduct it appropriately in Jamovi, and importantly, I'm going to help you make sure that you know how to analyze and interpret the results of the output that Jamovi gives you. So let's dive in. So first, let's talk about what a repeated measures ANOVA is. If you've seen the video on a dependent samples t-test, this is essentially going to be the ANOVA version of that. We're looking at changes between groups, but instead of those groups being comprised of two totally different sets of data or two totally different sets of people, we're analyzing the same group of data or the same group of people over time or in different scenarios. This is also known as a within subjects design. So we would use this in any kind of instance where we want to look at something like change over time or differences in how situations impact someone's reactions. These are places where we might use a repeated measures ANOVA. This is actually a really fabulous research design for other reasons as well. So one great thing about a repeated measures ANOVA or within subjects design is that you have more statistical power. And this is because in between subject designs, where we're looking at 2 different groups or 3 different groups of people, there's individual differences between those people that's going to create noise or introduce additional error into the analysis. However, when we have within subjects designs and we have the same group of data, then we're minimizing some of those individual differences and we have more statistical power. For my students out there or anybody conducting research, this can be really, really helpful because it often means that you need a smaller sample size in order to be able to detect an effect, which is super helpful when you're trying to get people to complete your survey, for example. Another reason why you might use a repeated measures ANOVA is just because it helps you track changes over time. Any kind of longitudinal study or anything where you want to do like sort of a pre-post kind of design, this is going to be really, really helpful for you. So I have the data set that I'm going to be working with today linked to the description below. Go ahead and pull that up and follow along with me, and we'll talk about how we can analyze this data. To run the repeated measures ANOVA in Jamovi, you're going to go to Analyze, ANOVA, and then you're going to select Repeated Measures ANOVA. There's going to be a box that says Repeated Measures Factors, and in that you're going to create a new factor and you're going to name it time because we're looking at change over time here. So you can label those as time 1, time 2, time 3, or if you had more specific information about your study, you might say like before, during, after. You can select the labels that you pick, but for this study in particular, we're going to use time 1, time 2, and time 3. Then you can drag and drop the corresponding columns, time 1, time 2, and time 3, into the repeated measure cells box. Now, I also want you to select a little bit more information. So I want you to select, because we're going to check the assumptions, I want you to select QQ plot, and then I also want you to do a sphericity check, also called Mauchly's test, and select that option as well in the assumptions tab. Now, let's talk about what these assumptions mean. So to back it up for just a second, an assumption is something that we have to examine prior to interpreting the results of a statistical analysis to make sure that our data has met certain criteria that tells us that we can trust the results that we've got. So here with a repeated measures ANOVA, we need our dependent variable to be normally distributed in the population. And the QQ plot is going to help us make sure that that is the case. Then we also have an assumption that's new if you've been watching the other tutorials called sphericity. You can think about this as the repeated measures ANOVA version of homogeneity of variance. So sphericity is also going to be looking at variance, but in the within subjects design kind of way. We don't have to dig into that too much in this video. If you want more information about sphericity, just leave a comment and let me know, and I'm happy to do that. So for our QQ plot, what we're looking for is that the little dots along the line up pretty closely to the line. We want for those dots to be really closely clustered to that line to indicate normality. If we see deviations and significant deviations from that line, then that would tell us that, we maybe have violated normality. So we can take a look at that here and see that we're looking pretty good for the most part. There's also a test called the Shapiro Wilk test that you can ask for Jamovi to run for you, and that can give you even more information about normality as well. Then let's move on to the sphericity test. So as I mentioned, this is also called Mauchly's test, and it'll give us a p-value. If the p-value comes back as greater than 0.05, that tells us that we have met the assumption of sphericity, and that's good news. If the p-value comes back as less than 0.05, then that means we have violated the assumption of sphericity. This happens fairly frequently and within subjects' designs. And so Jamovi has already put into place a really easy correction factor that you can apply. You're going to see there's a couple of options for correction factors that you can apply if you violate sphericity. In this situation, I usually recommend the greenhouse geyser because it's less conservative than some of the other correction factors. So I recommend using the GG correction factor, as we call it, but there are other options there as well that you can choose from. So now that we've determined that we have met our assumptions, I'm also going to have you scroll back up, and I want you to select effect size and partial eta squared, and also you can ask for the descriptive statistics under the additional options for the repeated measures ANOVA. Now that we've got all of our output over here in this section, we can start to take a look at what it is and what it means. Let's look at the main ANOVA results. So we've got a couple of pieces of information here. We've got the within subjects effects, we've got our degrees of freedom, our value of F, and importantly, we have our p-value here. Here, our p-value is less than that threshold of 0.05, is actually less than 0.001, indicating that there is a statistically significant difference in bench press amounts across time points. And then we also have our partial eta squared. That's our effect size for ANOVAs, and we interpret that as variance explained. So if you move the decimal point over 2 places, you can interpret partial eta squared as around 10.7% of the variance in bench press can be explained by time. And that is, 10.7%, that's a chunk, right? So that's a decent effect size there. So we have a statistically significant p-value, and we have an effect size. But however, we've got 3 time points here. So we have time 1, time 2, and time 3. We know that there's a statistically significant difference somewhere in those 3 time points, but the overall ANOVA doesn't tell us where the difference is. It just tells us that there is a difference. So what we need to do now to figure out specifically where that difference is, or to localize that effect, is to do something called post hoc testing. Luckily, this is pretty easy to do in Jamovi. You're going to click post hoc test, and then you're going to select time and move that over to the right-hand box. Then you're going to see that there's a couple of different correction factors that you can select from to apply. Most of these are going to be doing really, really similar things. They're trying to control for the inflated type 1 error rate that happens when we run multiple analyses. I like the Bonferroni correction factor because it's something that's also easy to calculate by hand. However, you might have a preference for a different correction factor, and that's totally fine. As I mentioned, the interpretation is going to be the same. They're all just doing slightly different things to the formula to control for that type 1 error rate. So I'm going to click on the Bonferroni correction. If you have a preference for something else, feel free to do that instead. So now we've got a table with a series of pairwise comparisons, which are just t-tests, right? So these are just dependent samples t-tests that are looking at the difference between time 1 and time 2 and time 3, and time 1 and time 3. So we've got 3 different pairwise comparisons. And just like with our overall ANOVA, these t-tests are going to give you the value of t, and they're going to give you that Bonferroni corrected p-value, which is excellent. Now we can know where specifically that significant difference lies while controlling for the type 1 error rate with that correction factor. So we can see here that the difference between time 1 and time 2 is not statistically significant. The p-value is greater than 0.05. However, the difference between bench press at time 1 and time 3 is statistically significantly different, and from time 2 to time 3 is statistically significantly different. So if we wanted to visualize this information and maybe even get a greater sense of what's going on, we can ask Jamovi to give us a plot. So we can click the Plots tab. You're going to check estimated marginal means, and then you're going to move time as the x-axis variable. And you're going to be able to see here what we've seen in some of the other data as well, that there's an upward trend going on. As time progresses, the athletes' bench press maximums also progress. And there's a statistically significant difference in that progression between time 1 and time 3, and between time 2 and time 3. So what are our final takeaways here? Well, using a repeated measures ANOVA is a really good choice for tracking changes in the same group over time. We checked the assumptions, those were normality and sphericity, and found that we didn't violate them, so we were able to move forward with the analysis. We had a statistically significant overall ANOVA, so we needed to conduct some post hoc testing. If you have any other questions at all about repeated measures ANOVA, how to do that in Jamovi, or anything else like that, feel free to leave it in the comments below, or you can reach out to me at ajoytoteach.com. Thank you. Bye.